Okay, greetings. Today we will be doing an introduction to electric circuits. Okay, so this is to ensure that you are not shocked during your exam time. Okay, so we'll cover these things from they move from your grade 10 until today, your grade 12. Okay, so when dealing with electric circuits, we've got amperes. Okay, like this. This is what we will use to measure our current. Okay, and then we have charge, which is in coulomb. So this charge in coulomb, right, which is C. Okay, and then we have electric current. Okay, so now this electric current is measured in A, which is this here. Okay, so let's move. How then do we represent this electric current? Okay, so this is a rate of flow of charge. What do you mean? It's a rate of flow of charge. That means we have our electric current, we have a charge here, which uses electrons, then it's going to have a change in time. So as these charges move, we measure these charges and the time they take. Okay, so then we have ohm. So ohms, we use them to measure our resistance, right? This is to measure resistance. This is a unit for resistance. Okay, so this is a unit, air units. Okay, so this is a unit of measurement of resistance. Actually, let me write it like this. So unit of measurement of resistance. Okay, what is resistance? We will see. So now let's come here and say, what is resistance? So resistance is what we have here. What is resistance? Okay, resistance is actually, we can represent it as a ratio of the potential difference and current. Okay, but that is in terms of Ohm's law. Okay, then we have a potential difference, which is this potential. Actually, let me use this color here. Have potential difference. So this actually here can be also known as voltage. Okay, so we already know that this is gonna be in volts. It's measured in volts. Okay, so now this thing here is equals to V, our charge here, which is Q. The charge is in coulomb here. So this one, unit measure of charge. Okay, so now this is Q, then this is gonna be over W. Okay, which is work. Right, so let's move and see. Okay, we're gonna have something called a voltmeter. This is used to measure voltage. okay, used to measure voltage or potential difference, okay, like so. And then we have an ammeter like this. This is used to measure current, okay, to measure current, okay. So now there are a few notes that you must note. So these notes here, let me find another color. So note, a voltmeter has a very high resistance. So what does this mean? This means no current passes through the voltmeter, right? So there is no current that passes through a voltmeter, but it can pass through an ammeter, because an ammeter doesn't have a very high resistance, okay? So let's come here so that I make an example for you, okay? So we have this little box here. This box, we're gonna call it our resistance. And then we're gonna have our wires. This is our wires. And then here we're gonna have something like this, okay. And then let me put a battery here. This is our battery. And then like so, okay. So this gap that I've left here, I've left it for my ammeter. All right, so this is gonna be A for an ammeter. This is gonna be R for our resistance, which is in ohm. Then this is gonna be our battery here. You can have it as 9 volts or whatever that we want. So now my point of drawing this was to show you that actually we can have a wire like this, another wire here, and then another, and then have another circle here. So this circle is going to be representing our voltmeter here. So the reason you can see that our voltmeter, we only put it parallel to whatever that we want to measure, okay, to whatever that we want to measure. So now it means we have this type of thing here. If we were to put our voltmeter the same manner that we have put our ammeter, then we wouldn't have any electricity flowing through here, okay. Then here with this resistance here is gonna reduce our electricity in a type of way. So now if we've got this ammeter, it's gonna measure the current, and then we've got this voltmeter, and then we've got this resistance. This is the simplest circuit you can see, okay. That is how you put it. So even if we were to put, for an example, want to measure voltage across this resistance, we'd have to put this V here, right? Then we'd have to measure like this, okay. Hope it makes sense. And then we have some fun stuff. Let's dive into series and parallel, right, circuits. So let's start with series circuits. Series circuits, okay. What do we mean by series circuit? So a series circuit, what I'm talking about here, I'm talking about these boxes that I've shown to you. I've got this box, I've got my other box, I've got my other box here. You see, they are lined up, they are following each other. So I can have something like this, my wires connecting these boxes. Okay, so let me give a name to these boxes. So these are resistors. So I'm gonna say this is a resistor 1. This is, okay, do this, go back a bit. Okay, this is a resistor 1, resistor 2, and resistor 3. Okay, so now these are in series. Okay, so let me write it here. These resistors are in series. They follow each other. And then we've got a bunch of rules for series things, okay? Or series resistance. We've got rules around here. So, number 1, let's say we want total resistance, okay? Let's put them here, rules. So, if we want total resistance, okay, of this small circuit, then we would say R total is equals to R1 plus R2 plus R3. This is because they are in series, okay? And then same thing comes here. So remember, before I started with this, I had told you that when we want to measure, let me do this so that I can do an example for you. Okay, so we've got these resistors again here. Now that means if we wanted to measure voltage across these resistors, we would have something like this. This is R1, R2, R3. So we'd have things like this here. Okay, like this. Okay, so this is gonna be our V1, V2, V3. Okay, this is how we measure voltage here. So that means if we want total voltage, would have to say Vt is equals to V1 plus V2 plus V3. Okay, this is for voltage. Okay, and then we have something called current. So now, how do we then represent our current in this series circuit? So that means our current in this case would be I total, but current is special in a series circuit. It means it's going to be I1 being equals to I2 being equals to I3. So current in a series circuit remains the same. Okay, so let me write it here. Total current. So say current in a series circuit remains the same. Okay, that means IT equals to I1 equals to I2 equals to I3. Right, so it remains the same, but let me say but here, but voltage is divided, right? Hence we had to add it. It's divided. So if we had 9 volts here, if we had 2 resistors, then this voltage would be divided across these 2 resistors. Okay, so let me do an example on this other side. So we're gonna have a circuit here which is like so. Okay, and then we can put a battery here. We have R1, R2. If they say this is 9 volts, okay, this 9 volts here is gonna be divided between these 2 resistors. Okay, so depending on the amount of each resistance. So theoretically, if let's say R1 and R2 are equal in this case, so that means let's say this is 3 ohms, then also this is 3 ohms. We can potentially have the same voltage across, okay, and the same current, but this is for when these resistors are equal, right? But it's not always the case, so it's better to calculate them. So this is as an example, it stands like this. Okay, and then we have a parallel circuit. Okay, so for a parallel circuit, let's do parallel circuit. Okay, if you know these things, they form fundamental of everything that we'll be doing here onwards. Okay, so we have what is parallel. We have something like this, my boxes, but this time I won't make them as nice, so I'll just write like this. Okay, so let me connect all these boxes here. Okay, doesn't look good, but I can connect them. Then I need a wire to connect to power supply or source, like so. Okay, then we have R1, R2, R3. Okay, this is parallel. They're more like stacked together. Okay, so the way we measure current and voltage still remains. If you want to measure voltage, we can measure it like this. Put it here. Then you can measure voltage here. Okay, so now let's start with voltage actually. So I will put the same thing here. I'll put it the other side so that it becomes easy to work with. And then I'm gonna have another box here, another box here, and then let's do it like this. Okay, so now this is what I have here, the same thing that I have on the other side. This is my R1. Okay, R1, R2, R3. Okay, so if I wanted to measure voltage across this R1 here, I would have to put something like this here. Okay, let me put it nicely also. So I can put something like so. This is my voltmeter here. Okay, it's fine. So let's just assume this is all connected like this, because these are wires. So this is V. Okay, so you can see that this voltage here is gonna be measured even if I put another here and put another here. Okay, so how this thing would be then, let me write it here as the rules. So it means we're gonna have VT, which might be our source, then it's gonna be equals to V1 equals to V2 equals to V3. Okay, remember series circuit are potential dividers, so you can say potential dividers for series circuit. Okay, this is for series circuits. Series circuits are potential dividers. And then here, the potential is not divided. Okay, so now it also means we have current. This is for voltage. And then for current in parallel, current is then divided. Okay, so this is current is divided. So that means the current in R1 and the current in R2 won't be the same, and the current in R3. Okay, so here we can say current divider for a parallel circuit. So this in a form we can say IT equals to I1 equals to plus I2 plus I3, because it's divided. Okay, and then we have resistance finally. So finally we have resistance. Now resistance here is different also. Resistance. So remember, for a series circuit we were summing R1 plus R2 plus R3. But in this case, we're going to say 1 over RT is equals to 1 over R1 plus 1 over R2 plus 1 over R3. This is how it is. Okay, but let me make an example before, because this one gets a bit, it changes a bit at the end. So I have R1, R2, R3 here. So then what I'm gonna do is this. Okay, is this like this, and then I'm gonna also do something like this here. Okay, so it means now I have, let me give these names, R1. Okay, so R1 equals to, let's say, 2.5 ohms. My ohm doesn't look good, it's fine. R2 equals to 3 ohms. R3 being equals to 5 ohms. Okay, so to calculate the total resistance in this case, we can say total resistance is equals to 1 over RT equals to 1 plus R1 plus R2 plus 1 over R3. Okay, so that means 1 over R2 or RT is equal to 1 over 2,5 plus 1 over 3 plus 1 over 5. Okay, so once you have punched in your calculator here, let me see if I punch in my calculator, and then plus 1 plus 1. Okay, so now let me say I have something like this, 0.93, right? So this is not the end, so you need to change this. Okay, so how do you change it? So how it works is you turn it upside down. RT becomes RT over 1, and then 0. This becomes 1 over 0.93. Okay, how then did this come about? So how this came about is that, let's take it from here. So let's take it from 1 over RT. Gonna have 0.93. This is over 1. We can cross multiply like this. We're gonna have 1 equals to 0.93 RT. And then let's divide by 0.93 both sides. Okay, and then we end up with RT being equals to 1 over 0.93. Then don't forget to put your ohms. This is how this becomes. Okay, so punch this correctly in your calculator, because I'm not sure the exact number if it's this. If you punch this, then this number then follows in the root. Okay, coolies, let's move. Okay, now remember I told you something with current. So current, you can calculate it using Ohm's law. Okay, we have something that we call Ohm's law. This was a guy who found this. Okay, but Ohm's law says here is that V is equals to IR. Okay, this is your voltage, your current, and then your resistance. Okay, this is to calculate voltage. We can change these things to calculate whatever that we want to calculate. Okay, in this case we can say, let's say V equals to IR. If we divide by R both sides, we can get current. So we can calculate current as being equals to V over R. Okay, but don't worry about this too much, because it all comes from this formula here. Okay, we're just rearranging things. Then we can do the same for resistance. We can have V equals to IR. If we divide by I both sides, which is current, then we can have R being equals to V over R, like over I actually. Okay, like this. So don't worry, if you know this formula, you can rearrange it to get whatever that you might be looking for at that moment. Okay, and then let's represent current like this. Remember, set current is So this is the rate of change of charge, okay? Current. That means rate of change of charge, we have current, we have the charge here, then we have this rate here, the change in time, okay? This is our charge in column. And then we have change in time, in seconds. Then you have current here. Then this is amperes. Okay, this is the rate of flow of charge. Current, rate of flow of charge. Remember the definition so that when they come, you don't have to worry. You get happy. Okay? And then we have these laws here. Okay? These laws, but it's fine, we can do the laws. We have the law of conservation of charge. Law of conservation of charge. Okay, so now here in simple terms, the total charge in an isolated system will remain constant. We know that charges cannot be created or destroyed, but we can just transfer from another form to another. Okay, when you wrap your hands together, you get heat. You have not actually created charge, you have just changed it from one form to another. Okay, so the total or net charge in an isolated, please do not forget keywords. Okay, these keywords, because if they are not there, then they might wrong you. Okay, in an isolated system, remain constant. Okay, let's say during a physical process. Okay, so we know that charges cannot be created or destroyed. Same as energy. Energy cannot be created or destroyed. Okay? Right. Let's move then. Let's see now, what do we do? Okay, remember with potential difference. With potential difference, you measure it between 2 points in parallel. Okay? Potential difference. So, this is the difference. Let me just write it like this. Okay, in electrical potential energy between 2 points in an electric field, like so. Okay, it is fine. So let's go back here and see. I might have did my things upside down there. We're gonna fix it, don't worry. Okay, so let's do an example and see if we know what we've been doing so far. Okay, let's do example 1. So I'm going to put everything that we've done so far. Okay, let me do this. Let me draw my circuit. So I'm gonna have a battery here, which is my supply. Okay, let me move back down a bit. It's fine. Let me do it here. And then have these wires here. I'm gonna have 3 resistors. Okay, I'm gonna have 3 resistors. Let me do it like this. Okay, we have 1, we have 2, we have 3. So now they didn't come out good, so let me do them like this. Coolies. Then another one. Okay, so here we're gonna have R1, R2, R3. Okay, and then let me give us our source here as 9 volts. So that means what we are measuring across our battery is 9 volts. Okay, so now let's say in this case we have R1 is equals to 1 ohm, R2 is equals to 1.5, and then we don't have R3. Okay, and then maybe let me see how I can do it. Let me give you also the voltage here. So we can measure voltage here. Okay, let's say here we have 2 volts. And then here we have 3 volts. And then here we don't have anything. We don't know. So we need to find what is the V here. Okay, so far what we have learned, this is gonna make things easy for us. Number 1, so things to check for. Okay, number 1, is it series or parallel? Like this, because sometimes it can happen to be both, so you need to know what you are doing. Okay, it shouldn't surprise you. So once you know if it's series or parallel, then you go back to your rules. You must remember your rules. Okay, already we know that from the rules we have Vt being equals to V1 plus V2 plus V3. Okay, this is just from the rules, and from that we can simply calculate our V, this one which is unknown here. So that means Vt is equals to 9 volts, which is our source here. So that is going to be 9 equals to V1 is 2 plus 3, which is V. Then V3 is going to be equals to what? We can simply say 9 equals to 5 plus V3, right? And V3 equals to 9 minus 5, like this. Okay, that means V3 is equals to 4 volts from just the rules without even going far. Okay, and then and then let's see this R here. How do we then calculate R? Okay, we know from the rules again. Let's go back to the rules, or rather the formula that I gave you. V equals to, let me use another, V equals to IR, like this. We already have the V as 4 for V3, so this is gonna be V3, I3, R3, like this. Okay, so now we have introduced I, which we don't know in this case. What is I? Okay, so what we can do, we can calculate I. So we can calculate I for any of these resistance. So let me calculate I for V1. So for R1. So this is gonna be V1 equals to I1 R1, like this. Okay, so V here in this case is 2 equals to I1 and then times 1 ohm. So that means I1 equals to 2 amperes, like this. Okay, this is my answer. But from the rules, remember, from the rules, let me just divide this page like this. Okay, from the rules, we must remember that IT equals to I1 equals to I2 equals to I3, like this. Okay, then it means I3 is equals to 2 amperes also. Okay, so now we can calculate our R3. Let's take V3 equals to I3 R3. V3, we've already got V3 as 4, so we can say 4 equals to I3, we have it as 2, then have R3. So that means we can divide by 2 both sides. Then that means R3 has become 2 ohms, like this. Okay, so now do you see how simple it becomes? Okay, this is how simple it becomes once you've got your things in order, your rules in order. Let's try example 2. So these things are gonna allow us to be able to solve complex stuff. Okay, so here I'm going to, let's do again another circuit, but now we're gonna do a parallel circuit. Okay, so let's do like this. Okay, we've got a parallel circuit. Like so. Okay, let me undo. And then I have something like this. Fine, can work. So here, let's say in this case here, I have 6 volts. Okay, like this for our source. This is our ammeter. And then we have R1, R2, R3. Okay, let's do the same thing, right? Let's say we don't have R3, So let's say here we have 5 R1 equals to 5 ohms, then R2 equals to 0.2 ohms. Okay, so now how would you then, let's start here. We forgot to do the total resistance, but we know that total resistance RT equals to R1 plus R2 plus R3, like this. Okay, but then in this case our RT would be 1 over R1 plus 1 over R2 plus 1 over R3. Okay, then remember again, let's go back to our rules. We know that Vt is equals to V1 equals to V2 equals to V3. So that means it's equals to 6 volts. So here we're going to have 6 volts, 6 volts, 6 volts. Okay, doesn't get divided. So this is going to be 6 volts. This is actually 1 over RT. It's not just RT. This is 1 over RT. Okay, and then we have IT equals to I1 plus I2 plus I3. Okay, now let's calculate our stuff here and see. Let's starting with our RT. We can say 1 over RT equals to 1 over, but we won't be able to because we don't have R3. Okay, so in this case we have 2 unknowns, so which makes it impossible for us to work. So let's name this as 30 ohms. Okay, then we can work with it, because what happens is you won't have I, you won't have R, so you won't be able to calculate this, the things that you're looking for. So now let's say we have RT, gonna do something else, 1 over 5 plus 1 over 0.2 plus 1 over 30, like so. Okay, and then you can use your calculator and remember, change the thing upside down, then you're gonna have an answer there. Okay, but now what I'm interested in is IT. What is IT or I1 or I? So I'm interested now in current, the current in this circuit here. Okay, so we have V here, we have also the resistance. Okay, so that means we can calculate our I. We can even calculate the total I. Okay, so let me do it like this so that you see. Remember, V equals to I R. Let's start with 1, with V1, R1 actually. So V1, we already have it. So let's start with I1. So if we want I from this, we can divide both sides. Remember, when I showed you this, we said V can be equals to I R. If we want I, let's divide by R like this. Then we'd have I being equals to V over R. Okay, so that means here we can have Y equals to V1 over R1. So what is the answer to that? Is I1 equals to V1 is 6 over 5. So this is going to be 6 over 5 ampere. Okay, for I2, same thing. I2 equals to V2 over R2. This is going to be 6 over 0.2, then amperes, like so. Okay, then we move to this side. here. And then that means here I'm gonna have I3 equals to V3 over R3. That means I3 is equals to 6 over 30. That's gonna be amperes. Then remember, IT equals to I1 plus I2 plus I3. Okay? Or alternatively, what you can do, you've calculated this part here, then you also have the total voltage. Okay? Then you can calculate this A here, which is this IT. What I'm saying is, if you say IT equals to VT over RT, you should get the same answer. Okay? You should get the same answer between this and this. So I'll leave that to you to test it out. Okay? Coolies, let me do one last example. Then next time we move to a bit more complex stuff. Okay? Example 3. So now in this case, let's say instead, let me do it like this. We have this here, okay, like this. Then you have this here, like this. Okay, this can be R1, R2, R3, R4. Okay, now you have two things. So these things shouldn't confuse you, right? These things shouldn't confuse you. You just divide and conquer. Okay, how do we divide and conquer? First, look at this. This is parallel. Okay, and then once you've got this RT, I would have my updated this. So this one, let's say I update it so that I have my RT, which I'll get from R1 plus R2 1 over R3. Then I can get my RT, right? So not R2, let me use the correct one. So this is gonna be 2 R3, then R4, like this. Okay, then this is gonna be your RT. So that means what I would have here is my updated version. I would have like this, like this. Okay, so now this is gonna be your RT, then this is gonna be your R1. But remember, the logic here still applies for each of them. In case there is one unknown that you might be looking for, the rule still applies, and then here also still applies. Then when you get here, then you've got a series circuit, then which you must deal with. Okay, this is how it actually works. So you're gonna get different combinations of this. So you should be able to actually do these things, right? Okay, coolies. This is the end of our lesson, guys. Until we meet next time.